Did you know you can form steel using wood? It doesn't seem like it should work. Steel is stronger than wood, right? It's like rock, paper, scissors. Steel beats wood and wood beats rock. Although let's get real, paper beating rock is some physically unrealistic garbage. I'm getting a bit off topic here. I want to wear Crocs in my shop, though I'd really rather not be wagering my toes every time I do that. So I tried to buy steel-toed Crocs, but they don't exist. What? Come on, Crocs Incorporated. This is a huge business opportunity. In any case, their oversight is my opportunity. So I set out to make my own steel-toed Crocs, and not just a one-off. I want to make a setup that will let me mass produce them. And it mostly worked. So follow along as I show you how I pulled this off and why it's a surprisingly difficult problem. This was actually one of the harder projects that I've done lately. I was really shocked at the number of iterations that this took to get working. So before we can dive down into the nitty-gritty, there's a bit of housekeeping I need to take care of. A bunch of people keep asking me, what's the deal with your face? Hey man, you ugly or something? To be honest, there's a reason I haven't been showing my face, and it's that people tell me I look really young for my age. I'm just kidding. The real reason I haven't been showing my face is just that I've been wanting to focus on the projects. They are the star of the show. I'm just the host. But if it makes you feel better, I can show my face. Or not. Just let me know. I don't care. So I can't ignore the white elephant in the room, which is this backboard. I've been getting tons and tons of questions about it. So first things first, I don't plan to mass produce this. I make hardware products for a living, and the last thing I want to do with my free time is develop and sell cheap plastic novelties, even if they are fun. If there's enough demand, maybe there's a way to get this out in the world, but I'm not planning on making it myself right now. So another big question I've been getting is if I plan to make a V2 of this hoop, and the answer is yes. I'm already working on it. I have parts coming in, and the mission statement for it is all shots go in. Whether it's a line drive or a slow arcing shot, I want them all to go in. I'm pretty excited about this project. It's definitely going to be a lot more complicated than this hoop. This is really elegant as one piece. This is going to be a mess, I promise. But it is looking like it's going to be a tour de force of economical spot welded sheet metal construction. So I'm really excited about it. Third question, does this account for spin? No. So the other question I've been asked a million times is what is the technical drawing app I use? It's called Concepts, and if you do technical drawing for anything, you should have this. It is fantastic. It's an infinite canvas where you can just let your ideas flow. This is the only reason that I have an iPad. And I'm not affiliated with them in any way, just a happy customer. It's really good. Oh, and I almost forgot. I'm loving the comments. It's really awesome having all these experts in different fields chiming in and giving me tips. And I assume other people like reading them as well, but I have tool and die makers giving me advice on my stupid plastic forming tools. This is awesome. I'm trying to reply to as many as I can. It's getting hard, but please keep them coming. I love it. It's fantastic. Thank you. Now on with the show. So what I made is a tool that will let me take a piece of sheet metal and smash it into the shape of a steel toe cover for a croc. So look, I'm not a tooling expert by any means. If I say something stupid, you'll understand why. It took me 4 or 5 generations to get this tool mostly working. You're gonna laugh at my first attempt. In retrospect, it was stupid, but I don't know what I'm doing. So I'm gonna show all of it. I think that's where the interesting bits are anyway. If you're wondering why I'm making the tool out of wood instead of, say, steel or aluminum, the first reason is I want the challenge, and the second reason is price. Go online and look at the price of a 6x6 by 10 inch billet of aluminum. I mean, what, does it look like I'm made of money? Let's make sure we're all on the same page here. I have a croc, and I want to make a steel cover for the toe so that when a heavy thing falls on them, my toes don't get obliterated. And the way that I want to go about doing this is I want to take a piece of flat sheet metal and force it into the shape that I want. And the way that I plan to go about this is carving the shape that I want out of a block of wood, and then carving the inverse of that shape out of another block of wood, then putting a piece of sheet metal between them, and then smash this down super hard. And then hopefully the sheet metal will become that shape. The challenge here is that metal really likes the shape that it is, and if you try to force it into another shape, it's gonna fight you tooth and nail. So imagine I'm looking at a steel bar from the side, and I wanna bend it into a shape like this. So anyone who's bent a steel bar before knows that it doesn't just bend, you have to force it. The reason for this is that when you try to bend the steel, this side actually has to get squashed down, and this side has to get longer, and it does not wanna do that. So you might be wondering, how can steel get squashed? Isn't it incompressible? And there's some caveats, but it generally is. If I take a little piece of steel like this and I squish it down, it actually gets wider. The material does have to go somewhere. So if I bend this, it's actually getting fatter on this side and thinner on this side. Isn't that neat? These same things apply when you're trying to form metal in 3D,
but it's much worse. For example, imagine I'm trying to take a sheet of steel and form a bowl shape into it. If I was looking at it from the side, it might look like this. If I just smash this shape into the piece of sheet metal, this, just like the bend, this material has to come from somewhere. Either the metal has to stretch and get thinner, which it really doesn't want to do, or it needs to pull these sides in. If the sheet metal is this size and then I try to stamp this sphere into it, material pretty much has to come from the sides. And if you think about it, if I'm trying to pull all of the sides in, I'm basically saying I want to take this piece of sheet metal and scale it down, kind of like this. So newsflash, sheet metal does not want to do this. It will fight to the death. It will squirm. It will thrash. Wait until you see what I went through trying to get this to happen. So imagine taking this piece of sheet metal and trying to force it down to be shorter. It just bends. Just think about how much harder it is to compress this down than it is for it to bend. If it bends and compresses when you're trying to do this, then you get all kinds of bends in your part, which ruins the part. So this was one of the key challenges for this project, was finding a way to smash effectively a sphere into a piece of sheet metal, shrinking the outside enough and getting few enough wrinkles and buckling in this that I don't ruin the part. Basically all the iteration that I did was around this idea.
So I want to make a tool that will let me super smash sheet metal into the shape of a croc, but to do that I need to know the shape of the croc. How do I measure it? Do I use calipers? Those don't really work. Ideally I'd use some kind of 3D scanner or CMM, but I don't have access to one right now. And so I'm going to use my Tormach as a poor man's CMM. This actually works pretty well, especially if you have a probe, and I don't see people doing this very frequently, so you should try it out. Unfortunately the croc is too soft for my probe, so I'm just eyeballing it.
So the astute among us are probably already thinking ahead and recognizing the fact that if I'm using some kind of probe to measure the surface of the tool, so when it touches the croc, say for example here, the center of it is here, but the surface is actually here. So if I do this a bunch of times and I get a bunch of points and then I reconstruct it, I'm going to get some surface like this. It's going to be the croc plus the radius of this probe tip, and it's going to be the wrong size. And this is actually not totally easy to deal with. I can't just shift the points by the radius of the probe tip. To be correct, this one needs to go down, this one needs to go down and over, this one needs to go totally right. The way I'm going to deal with this problem is in the CAD. Once I generate this surface, I'm just going to offset it. The way that it works is each point will be shifted along the direction perpendicular to the surface at that point, which is exactly what we want.
The result of this is a bunch of points. I load them into my CAD program and then I fit a surface to them. Once you have the surface, it's pretty straightforward. You can see I'm offsetting it here to account for the probe radius like I was talking about before. I'll leave it as an exercise to the viewer from how to go to the surface to the tool, but it's very specific to the tool that you want, but it's straightforward. It's just cubes and things.
It looks like everything fits. I went and cut out a blank for the press. The idea behind the shape is it's sort of roughly the shape of the steel toe if I drop something really heavy on the toe and it flatten it out. And the way that I hope that this works is that this tip here will hit first, which will put a little bend in it. So as it goes into the form, it'll pull this end down into the form. There's not a whole lot else to say. Let's give it a try. It's not a very good look. A lot of the creasing was initiated in these back corners where the sheet metal was stabbed by these points. The reason I have this flat back here is so that the back of this form can press against the inner side of the core and just give me a good squeeze on the front. But I don't actually need it. So what I'm gonna do is machine this off just to make it smooth. Let's try it. This is the problem. It's completely jamming the part. I've now succeeded in making two pretty ugly pieces of garbage. So one interesting thing about these is that they're unbelievably stiff compared to the raw sheet. And that's because they have this nice curvature to the top of the surface. This is how they make cars. They press form, for example, the door out of really thin sheet metal. If you saw the sheet metal that they make cars out of, you would say there's no way you can make a car out of this, but they do. Except for their parts look a lot nicer than mine. Speaking as a complete novice here, I believe what's happening is I'm just trying to force too much change into the material too quickly. One interesting thing is that the wood tools can definitely take forming the steel. Like, it's not really damaging it. If I can just get the right shape for this, I think I can form this. It occurred to me that there was one more thing I hadn't tried, which is worth trying before I go through all the trouble of making more forms. The idea is to press this way. The advantage of this is that it's doing a whole lot less drawing of the material because it's only going down a few inches. So I'll just see if it works at all. And I just quickly off camera CNC'd this out of it. The press ram will go into this hole. This will hold it nominally square, and then I will smash the metal down into here. This made a perfect slide. If this works, I'll make something actually proper. I still think what's happening, even this direction, it was less severe. Shoving it into this hole, there's no way to fold up the side edge and the front edge at the same time without getting a crease. Think about wrapping paper. You have to put the crease in the corner in order to fold around a corner. This is the sheet metal doing almost exactly the same thing. I've converted this little block of 4x4 into hopefully a serviceable tool. Who knew? Pressure treated 4x4s don't machine that well in a CNC machine with a roughing end mill. Probably no one knew because I'm the only guy trying to do that. The reason I'm using a roughing end mill is it's just all I have. The one other thing that I did is I took my press form mount and I chopped 45 degrees off of it so that it will go at a 45 degree angle into this as well. And so this stack up should avoid that whole sliding problem that I had because it's going straight in. All right, so all I gotta do is just get this mounted up and then we can give it a shot. So this is almost croc shaped. I'm still getting these creases in the corners, but would almost fit over the croc, which is kind of cool. It seems like the material is bending up and then that's allowing it to crease. And so what I'm gonna try to do is clamp the material to the surface around it and then press in. And my hope is that will constrain it enough that it can't lift up and crease. It's definitely gonna introduce all kinds of weird new stresses into the material and it very likely may be a complete fail. So let me quickly build some kind of clampy thing. Let's try it again. So from looking at the tool, what it looks like happened is the metal still forced the tool apart and was able to bend. But this does look a whole lot nicer than the previous ones. Do you know what's just the absolute worst thing ever? Is doing things the right way. It is just the worst. This is a totally from the ground up new set of tools that I think take all the lessons I learned with the other ones and do them more right. So I have the outer cavity here. This is what I'll be pressing the sheet metal into. There's a big smooth surface that it gets pulled down into, so there's no nooks or crannies for the sheet metal to fold into and get creased. And now it also has a lead out on this side, so the metal's getting pulled on all edges. And I think that'll help balance the forces and help prevent wrinkling. This tool is also strangely beautiful. I love the two-tone. So far, all the tools that I've made have been much more beautiful than functional. This is the new cavity tool. The reason it's on this cuboid thing is that I need to be very well located relative to the outer form. If it's not located well, it'll hit and then twist and it won't be able to get all the way in. This was a big problem with those previous hack tools that I had because they were attached to the press frame and that thing has an enormous amount of play and there's just no way they're gonna go right in the way that they needed to. What I do is I have this outer frame. It's made of 2x4s, but it really doesn't matter. This will slide into and it'll locate it as I press it down. This frame has holes for some precision pins. This sits on these pins and it locates it accurately to where this form is. And then the one final detail is I take the blank and I clamp it with 4 bolts when I set this on here so it gets pinched and can only go down into the hole. So I think that's enough talk. Let's find out if this was a giant waste of time or not. To the press. It's still generating enough force to bend this. Look at that. Isn't that crazy? The wood totally bent itself up into a little donut. I think if I could increase my clamping here, probably with a piece of steel, then clamp the heck out of that. That might be what I need. Wow. We almost have a steel toe. So this side is just about good. This side is good. This side is definitely a fail, but close. And this is the only really bad artifact. It's pretty amazing. You can see that this is not square at all. Wanted to get compressed down, but it just couldn't do it without buckling. I think this will work if I super clamp the material down with not wood. I think wood is gonna not be able to take it. So I just took some 3/16 plate that I had and cut out these clampy bits that will go between the upper clamp and the sheet metal. This will hopefully keep the metal from creasing upwards. And these parts turned out great. I think plasma cutters are really underrated. This is straight out of the plasma cutter. Look at that edge. This is about as much clamping as I'm gonna be able to get without changing the design. So I hope that it's enough. Bit of distortion, but greatly improved. This part. It looks like the wood just couldn't take it and buckled in. All right, we now have a piece of protective armor for the 4x4s. I'm gonna attach some extra clamping surface area so I can really get a bunch of clamps in there and super clamp this down. All that stuff I said about doing things the right way, yeah, it's out the window. This is actually fairly typical for prototyping, where you build a prototype, you learn stuff, and then you try to modify it to apply what you've learned to prove that it works. And then if this works, I'll probably make another one that does it more correctly, and it'll hopefully mostly work. There's no point in going and building a whole new one just to test what I learned, because if it doesn't work, then I wasted all that time. So that's why I'm building this in such a hacky way rather than building another revision. All right, it's the moment of truth. It's a lot better. Isn't this tool ridiculous looking? This is so stupid. The one little tiny crack between my two stiffeners, the steel shot up in between it. So there's ripples all throughout the outside, but within the formed area, the only real defects are from where it squeezed up into the space between the stiffener. We're definitely getting a whole lot better than we were. Let me see if I can find the original. One of these here is the original one. Yeah, I never claim to know what I'm doing. I just know what I'm trying to do. Oh, this is so tantalizingly close. Can I get it out of this tool without making another one? That is the question. I bet I could make it work if I just weld these two together so that there's no gap anymore. It's a wonderful thing when two become one, is it not? I think we just might be able to squeeze a good form out of this tool. Let's get this in the press. Oh, man. I now have a clamp on basically every location that I saw the metal bowing up before. Probably what's gonna happen is the metal's gonna find a new place to bow up. Probably two more are going to appear. But if we're very lucky, we'll get a pretty good form out of this. Oh, yeah. Perfect. Just kidding. I think it's almost what we want. Very cool. Wow, that's crazy. Look how symmetric this wrinkling is. It's like perfectly symmetric. Isn't that cool? And look, this side too. That is so cool. I'm gonna cut this out. The overall fit is pretty good, but the reason it looks so stupid is that as I redesigned the tool over and over again, I incrementally removed slices of the final form. The biggest chunk that came off actually was the radiuses for this final tool. I think I added almost a 1/2 inch radius to the tool, which took a 1/2 inch off this all the way around. So that's why it's so incompletely formed. So I have some ridiculously large wooden cubes. These are my new tool. This is the smallest of the cubes. And then this is the big boy. This is actually several 4x4, 2x4s glued together. And then they've been planed top and bottom so that they're nice and flat and they'll mate well with each other. The way that this is built is there's 2 levels, which are kind of the core guide. This big brick here is the core. It's a lot bigger than the previous core because I've re-digitized the croc and made it so that I'm actually getting the whole shoe. And instead of one of these lame kind of half steel toes, let's get these into the machine and get them machined and then hopefully give this thing a try. So, all the tools are done. I have the core guides. There's 2 of these. These are what guide the core down in the right spot when I'm pressing it, like this. And then, those are the most boring part. A lot of material to remove, really hard on the cutters. I've got the outer form. This is really cool looking. And I added these threaded rods in compression. This is so that I'm not relying only on the glue joints to hold it together, because this is the part of me pushing up on with the press, and I'm worried if I push in the center, it's gonna tend to snap it apart. I have this inset here, so I can take a piece of sheet metal that I just plasma cut and set it in like this. So this should protect the surface from denting. It's only 16 gauge. I have some 12 gauge and 14 gauge, but it's too heavy for me to get onto the plasma cutter by myself, and my wife is asleep, so 16 gauge is the size that I used. And I have a matching one which goes against one of these guide blocks above. The sheet metal that I'm forming will go in between. So the fact that the sides don't line up exactly just doesn't really matter. I wasn't actually even really trying to line those up. The thing that matters is that when you look inside of it, everything lines up. This is a result of how I machined it. Everything was machined with all the pins in the same operation relative to the same jig, so everything was using the same coordinate system and they all line up really well. So the core guides hold the core nice and straight and in the right spot, and it just slides in, down when I press it, and smashes the sheet metal in the right spot. You could say it fits like a glove really well. Just gotta modify the press, figure out the blank shape that I want, and then go for it. Maybe when I'm done with all this, I'll use the CNC to make some wooden croc clogs. They sound terrible to wear, but the novelty factor seems like it might be worth it. So everything's loaded up. If I'm gonna be doing this a lot, I'll bolt all these things in position so I don't have to manually align them. But notice that the pins are on the wrong side. Normally they're down below, but these are above because I'm pushing up with this bottle jack. The sheet metal is really firmly clamped by this bottle jack here. When this jack comes down and exerts a lot of force on the inside, it will actually reduce the clamping force between these two faces, because it's going to be pushing down on this bottom one against this jack, and as that compresses, this will uncompress and get less compression. I don't think that's a problem because the press doesn't develop significant force until the bottom of the stroke when I no longer need clamping. All right, the moment of truth. It still did curl up a little bit, mostly on that edge. Yes. So there's one wrinkle, but it is on the back side, which is what I'm cutting off, so that's fantastic. The rest of it, there's some very slight wrinkling on the front. The question now is, does it fit the croc? It looks like it will. Let me get this cut out and see if it fits. This is cool, very exciting. So I just sliced all the extra material off on the bandsaw. And I'd say that the quality is there, but the shape isn't quite right still. Mainly it looks like I really underestimated the spring back. I did actually try to correct that a bit in the tool. I gave it a 1.5 degree extra angle. But it looks like when you have a compound bend, and I think this makes sense, the spring back is more severe. If I want a mass producible part, say that I could sell, if there was interest, then I would need to redesign the tool one more time just to get this edge more straight. It looks like the spring back is like 10 degrees here, which is gigantic. You can see the really bad spring back here. It's not sitting flush on the edge of the shoe anywhere. It should be sitting flush. And because it's sprung out, it basically doesn't wrap around the edges the way that it should. This is definitely not ready for mass production, but the technique I think works though. This is pretty cool. I have another tool to make, but I'm pretty darn tired of making tools. I think I'll come back to this project, but let's call this tentative part 1 for now. You know, maybe if there's enough demand for steel-toed Crocs, maybe then I'll make them. I don't know if my demand is sufficient to go through the pain of making yet another tool, but I did learn a ton, and I am actually really happy with these results. I'll almost certainly be using this technique for future things where I need to make a bunch of sheet metal parts that are complicated. One cool thing that I would probably do if I was making this in mass production is I would use a 3D cut profile on the plasma cutter. So I would basically make a jig that holds the thing, and then I would cut out the shape on the plasma cutter and then finish the edges somehow. I think this is a good place to end it. You can use your cheapo Harbor Freight 20-ton press to press form legitimately nice parts using legitimately cheap wood tools. It does take some iteration to get the tool right, at least for something hard like this. I think if you had something that had less requirements in terms of fit, you might be able to do it in one shot. Hopefully you enjoyed it. Thanks.